All right, now we're going to be talking about rational exponents. So there's a lot of vocab in here and parts that you need to know, so it's very important. When we've done square roots before, there's always been an index there, whether it's been written or not. So this little number, that's called the index. That's going to be the denominator in your exponent. Whatever is under here is your radicand, that's your base, and then your radical is just the actual symbol. So now here's what we're going to do. This looks all kinds of crazy, but it's not too bad. All we're going to do here is we're adding this part of m. So you take whatever exponent is here and you make it the numerator. So the numerator is inside, the denominator is outside. And now we're going to rewrite using the radical. We're going to rewrite the radical to make it an exponent. So here's an example. And one thing I want you guys to notice is if you have 64 1/3, well, this is going to be inside, and this is your outside. And then once you take the cube root of 64, you're going to get 4. That's your answer. And if you notice, I wrote the 1 there. All right, let's look at this example. So again, the inside is going to be your numerator. The outside, which is your index, is going to be your denominator, and that's how you would rewrite that. So those are the same thing, just written a little differently. And then here, if it doesn't have an exponent, I always write an exponent of 1 in, just to make sure I keep myself straight and I don't forget any of the ones. So now what we're going to do is we're actually going to break this up. So we're going to take 16, and we're going to take the fourth root of 16, which is 2. And then that means if you're to have 2 times 2 times 2 times 2, 4 of those would go outside. All right, and then we're going to break this part up into 8 to the fourth root. So we've got 2, and we have all to the fourth root, m over 8. And then once you get here, they kind of skipped a step on you, but you should have 2 m, and then it should be 8 over 4, which simplifies to 2. All right, so here I did some color coding. Again, if there is no exponent written, write an exponent of 1, that'll help. And then your index is 3, which is the cube root in this case. So that's all you have to do is just write that. That one I want you to try. All right, let's look at this one. If no index is written, it's understood to be 2. Now, I wrote a 2 in there for you. We're so used to square roots, but it's really everything to the second power. So now we're just going to rewrite everything. So I got 1 as the numerator, 2 is the denominator, and then for x, 3 is the numerator, 2 is the denominator, and then for y, and then that's going to simplify to 4, and then this is how you would rewrite it. So again, if there's no index is written, then index is 2, and if no exponent is written, exponent is 1. All right, so now what you're going to do, or now what we're going to do is we're going to do number 5 real quick, and this is just kind of going the reverse of it, where you're going to write it in radical form. So we're going to take a radical, we're going to put x in there, so now you have to remember that 2 goes on the inside, 5 is the index. That's it. Now number 7 is a little tricky because for this one, they do not have a common index number. So think of like a common denominator. You want to get a common index first so you can put it all under the same radical. So if we were to have, 1/3, 1/4, 3/2, I would make them all with 12. So this is going to be 4/12. This would be 3/12, and this would be 6 times 3, so 18/12. So these are what I'm going to use for my indexes. So my index is going to be 12. Now they have a common index, so now we're good to go. All right, so let's go ahead and let's write this in here. And this is index of 12, but that's okay. And we said x was 4, y was 3, and z was 18. I'm going to extend that a little bit more. So let's just do a quick little check. I got 4, 3, 18. Okay, 4, 3, 18. And they all have a common index of 12. So we're good to go. All right, so this is your answer right here, not the actual fractions. All right, so now let's check this one. Now it says to express in radical form with constants only. So break the fraction exponent apart and then simplify. So the goal is you want to get an exponent you can simplify. So if you're using an exponent that doesn't simplify with the index, you'll need to see if you can pick another index or pick another exponent. All right, so for this one, what I did was I made this into 6 squared because 2 and 6 you can simplify. All right. Then 2 6 simplifies to 1/3. And then now I can actually rewrite this because remember 1's there, 3 is there, and then I just take the cube root of 6 and that's it. And then for 11, this one's a little tricky because you have to kind of know your numbers. If not, you can always do a factor tree. But in this case, I know 125 is 5 to the 3rd power, and I know 3 and 9 can simplify. So I'm going to rewrite this as 5, 3 to the 9th power, and then 3/9 is going to simplify to 1/3. Now that I've got this is really 1, and your index is 3, so it's the cube root of 5 to the 1st power, but we don't say that. That's your answer. All right, you're going to finish those. And then I do have an extra example I want you to try on your own, and we will go over this. But there's actually different ways. I'll give you one, I'll get you started, but I want you to finish it. One way is to think of this as and then you could simplify this and then rewrite it. Now remember, this 2 is here, but we typically don't write it like that. And then you can go ahead and simplify 8 to the 3rd. You're taking the square root of 64 3 times. So from there, and you'll get 8 to the 3rd, which equals 512. Now, what I want you to do is on this way, I want you to think about it. Oops. As 8 squared times 9, because 8 squared is 64 to the 9th power. So this is a little bit different way. So now I'm going to get 8 to the 18th power, and then there I can go 18 over 6, which is 8 to the 3rd. And we'll talk a little bit more about that later, but if you notice, that's where I got that. And then that simplifies a little bit easier, and you have a much smaller number to deal with, but you still get the same answer at the end. So there are different ways to do that. All right, so now write these down to remember your product rules. If you multiply the same base, you add the exponents. If you're dividing the same base, you subtract. If you have a negative exponent, you're going to take that and flip it to the denominator or flip it up to the numerator, depending on where the negative exponent is. And then when you flip it, you're making the exponent positive. And then here, if you're taking this and you're distributing, you're multiplying. So it's really A times B. So think of this as distributing. All right, I'll get you started on this one. You're going to do the quotient rule. So here, notice you're multiplying the same. So if you multiply, you're going to add your exponents. So 2/3 plus 1/3 equals 3/3, which is 1. And the answer is just A. I want you to do this one, but remember quotient rule, so you're going to subtract. Now this one is a little bit harder, but it's still the same process. What you're going to do first is the power rule. So power rule says you should distribute your exponent. I wrote in an exponent of 1 here. So go ahead and you'll get negative 1/3, and then you're distributing negative 1/3 to 2, and I got negative 2/3. And then now notice you have two negatives. So if they're in the numerator, I like to flip them to the denominator, and then I make the exponent only positive. Same thing here, flip this to the denominator, and I make that positive. Oops. All right, so go through. I want you to finish all the ones we did not do. And then that is the introduction to rational exponents.